All right, well, I'll switch back to start. So hi, everyone. I'm Erin Heffron. I am speaking to you from the control van of the EV Nautilus right now. We are in port, and so after I introduce myself and my co-presenter, I'll give you a little tour around the ship with cameras, and then we'll get into our presentation. So I'm Erin Heffron. I am an ocean mapper and navigator with Ocean Exploration Trust, and I do go out on other vessels as well. I'm a Slippery Rock graduate from 2004, BS in Environmental Studies. And my co-presenter is Alyssa. I don't know if you'll see her face because of how we're set up, but Alyssa, go ahead and verbally present yourself.
Okay. Hi, I'm Alyssa Snyder. I'm a recent graduate from Slippery Rock with a BS in Environmental Geoscience. And I will be an intern on the seafloor mapping team this next expedition that they're doing for the OET.
Yeah. We're looking forward to having her out. She should be here now, and we should be transiting to Hawaii right now, but we had some ship repairs that needed to be done and things, so we are stuck in port. So hopefully you'll see my face again. I'm gonna try switching, before I go to my presentation, I'll try switching to show you the ship a little bit. So like I said, I'm in the studio, and let's see if we go, if you're looking where my face should be, hopefully you see the bow of the ship. So we're in San Pedro, California. That's our home port. And this is a good time to acknowledge that I am living and working on the ship and in San Pedro, California. That is the home port of the Nautilus. And San Pedro is within the traditional and modern lands and waters of the Tongva, Kizh, and Chumash people. And we thank them for their ongoing and continuing stewardship and historical stewardship of this land. So that's the front of the ship. I can show you maybe the back view. So that's our deck view. And so we're loaded up with a bunch of vehicles and containers because this is the last time we plan to be in the continental US for up to 3 to 5 years. We're headed out to the Pacific for extended exploration. Another view I can show you is the hangar. Nope, that's the front of the ship. Let's get 6. That's the ROV hangar. Usually ROV Hercules is in there, but our major ROV, which I'll explain in my presentation, is in the warehouses next door getting repaired by the ROV team. We did have a very exciting moment where we lost 2 of our ROVs this year, but we got them back. And though they survived that quite well, the team took the opportunity to do some repairs. All right, so I'm going to switch to hopefully my presentation. Hopefully that's what you guys will see now. All right, so Alyssa and I are co-presenting today, and our presentation is Western PA to the deep ocean and how we both got on the EV Nautilus. So outline of my presentation, I'm going to start with a little introduction to Ocean Exploration Trust and the EV Nautilus. And then I am going to talk about my path from Slippery Rock to Nautilus, and Alyssa is going to talk about hers. She's not quite here yet, but she's close. She'll be here soon. And then I was going to talk about just briefly some of my favorite past expedition highlights that I really enjoyed. We'll talk a little bit about NA-132, which is the expedition Alyssa will be on with me and beyond for this season. And then we'll finish up and see if you guys have any questions or anything you want to talk about. So starting with an introduction to EV Nautilus and Ocean Exploration Trust. The trust was founded in 2008 by Dr. Ballard. He's most famous for finding the Titanic and hydrothermal vents, but he has done other things as well, and he is still an active participant in our expeditions and outreach. Our ship is an exploration vessel. That's what EV stands for. So we are not out doing hypothesis-driven research. We're doing exploration. Trying to do things go see things that people have not seen before and really push the envelope. But one of our big parts of what we do is making sure that we always tell other people about what we're doing. So we broadcast all of our ROV dives, all of our missions, live streaming to the world. We have satellite internet, so we are always showing people what we're doing on our website, Nautilus Live, which I'll also be showing some screen captures from. the ship is 68 meters long. We can do 33 member science team. So that's students, interns, educators, engineers, anybody who's not professional crew. And then we have 17 professional crew, mariners, able-bodied seamen, bosun, things like that, who maintain the vessel for us, as well as stewards that feed us and chefs and stuff. And we get sponsorship. A lot of our sponsorship does come from NOAA, Ocean Exploration, Office of Ocean Exploration. Sometimes we have additional private sponsors. We've been sponsored by National Geographic and such in the past. So it really depends on what the year's missions look like, who is helping to fund our expeditions. This is what our season looked like this year. So we started it in San Pedro, where we did our shakedown. We moved up the west coast, doing some mapping up to Astoria, and then up to Sydney, BC, where we did some work for Ocean Networks Canada. This is really cool engineering work, where we're laying cables and doing some maintenance on the ocean observing network on the seafloor off of the west coast of Canada. Then we came back down the coast, and then we just were out on a technology demonstration, which was super cool with our Cooperative Institute partners in Woods Hole, testing 2 of their vehicles and the ability to use their vehicles on our ship. And it was just super cool and super exciting. Next, Alyssa will join us and we'll be heading out to the Hawaiian Islands. And then the rest of our season this year will be in the Northwest Hawaiian Islands. And then next year and beyond, for several years, we will be in the Pacific, either Hawaii or deeper into the Pacific, maybe returning to Samoa, Baker, Howland, some of the more remote Pacific islands that we've been to in the past several years, but we're going to be actually staying out there this time instead of coming back to San Pedro. So if you're not familiar with our ship or what we do, kind of our main workhorses are our ROVs, remotely operated vehicles. Our large working class ROV is Hercules. Hercules is on the top left there, has a manipulator arm, 2 manipulator arms for sampling and tying knots and plugging in cables and whatever else we need them to do. Can take biologic samples, Niskin samples, et cetera, and can be set up to do lots of different things. So they rig Hercules differently depending on the mission. And then Hercules partners with Argus. It's a 2-body ROV system. So Argus is above Hercules. Argus is on what's called a 6/8 wire, which is attached to the ship. And then from Argus to Hercules, there's a tether, and there's fiber optics through all of that. So everything Hercules and Argus see or sense with the different sensors on board are broadcast back to the ship immediately. So we're watching from the control van where I'm sitting, the ROV team and the science team. We're getting all that information back nearly real time, pretty close, closer than you would be able to think about it. And we are making active decisions about where we want to go explore, things we want to sample, et cetera. We also have a smaller ROV, Little Herc. Little Herc does not have sampling capability, but can go deeper, can get down to 6,000 meters. And again, that is a 2-bodied system and partners with Atlanta. And the point of the 2-body system is that the Argus or the Atlanta, who's above Hercules or Little Herc, dampers the motion of the ship, so you don't get a lot of movement, and also serves as kind of an overview. So it helps us get really great imagery of what Hercules is doing and what we're doing on the seafloor. Nautilus is also equipped with the mapping system, and so this is what Alyssa will be helping with on our way to Hawaii. We will not be doing ROV work on the way to Hawaii. We'll just be transiting and mapping. So on the hull of our ship, we have a Kongsberg EM302 multi-beam sonar. It's 30 kilohertz and can get to about 6,000 meters, not quite full ocean depth, but covers the broadest range of ocean depths. We also have a Knudsen sub-bottom echo sounder, which can penetrate the seafloor and get information about layers and stuff below, so more interpretation of past geology. And then to support those mapping systems, we have 3 ways to get sound speed. I'll do a brief talk about mapping, but you need to know the sound speed through the water column in order to map the seafloor. And so we have a sound speed sensor at the transducer that measures sound speed continuously, and that helps with the multi-beam beamforming. And then we have an underway CTD and expendable bathythermy thermographs. So on the left, we have people, bottom left, that's my partner Lindsay and one of our seafloor interns deploying an underway CTD. And then in the middle, that's what an XBT looks like. It is expendable, so it gets dropped into the ocean. It sends back temperature information to the ship, And from that and the World Ocean Atlas, we can get a good feel for what the sound speed is in the water column, put that into the sonar. And so, like I said, we're broadcasting all of this all the time, 24/7 through Nautilus Live. That's our website, screen capture of our website on the left. In addition to doing the broadcast, live dives, you hear us talking on what's called SPL, or Science Party Line, when we're in the middle of the dive. When we're doing mapping, we don't talk on SPL, but we'll do a lot of interactions. And in the midst of all this, we do hundreds and hundreds of live interactions every year. So from the studio where I'm sitting now, we'll be broadcasting out to school groups, church groups, community groups, whoever wants to talk to us. You can request a live interaction at any time, nautiluslive.org/education/ship-to-shore interactions. And we will do our very best to accommodate you. Like I said, we do hundreds and hundreds of them. We also do a lot of Facebook Live events, Instagram Live. We have a whole outreach team that really keeps us going and makes sure that we're sending our message to the world. And when we're in the middle of a live dive, while we're broadcasting it, this message system on the website opens up and you can type in a message. And there is a person sitting here in the control van with us who will ask us your question. So you can interact with the ROV team, navigators, etc. The bottom right, that's what the control van looks like when we're in the middle of the dive. I love this picture. You can't see, but in the front row, it was our first full female front row. So I was the navigator and I had 2 female ROV pilots. And you can't tell that, but I know that that's the story and it makes me just incredibly proud. That was during our Santa Barbara Basin dive, I believe, last year. So that's what the control van looks like.
Erin. We're proud of you.
It's a really amazing experience, and this is an amazing ship to be on for the amount of strong female presence that's always a part of all of our expeditions. And then we're always collecting data, of course, and we make that data available. So our mapping data all goes to NOAA NCI through what's called rolling deck to repository. So you can get our mapping data, our ROV data also available. So I've just listed it out here. You can also find this information on our website. So if you're interested in any of our samples, our video data, our multibeam data, any of the above, it is all available to anyone who wants to work with it. So available to the world. All right, so now I have to talk about me. So I am an ocean mapper. I'm a mapper by training, and I've been trained to be a navigator on the ship. This has been an amazing opportunity that you don't really get on other ships. So Nautilus specializes in being a training vessel. And so that opens up opportunities that you wouldn't necessarily get on other ships, which is pretty cool. So as a mapping coordinator, I help plan mapping transits and surveys. I process the multibeam data. That's what my training is. I produce maps and other products to go into the archives like NCEI. During diving missions, I am a lead in assisting for dive planning. So the scientists and the expedition leaders will come down and they'll hover around my back in that station there, and they will plan the dive right there on the multibeam data, which is fun and exciting. And then we'll put out dive plans for the general public and for scientists ashore. I forgot to mention that we also always have scientists ashore who are following along, commenting during expeditions, putting in their input, and are available to help comment if we're having trouble identifying a feature or biology or whatever. I generate maps for the ROV team and Navigator, and I help train new mappers and interns. We are an educational ship, so we're always bringing new people on. As a navigator, I am front row with the ROV team. So that's me in the bottom right picture. I'm in the right corner. That's the navigator position. And that's, again, our all-female ROV team, or front row team. I had Jess Sandoval as our Hercules pilot, and Kylie Pasternak as our Argus pilot. Super cool experience, and I believe it was Halloween, too. So it was just a special day in general. And we were running a dive, I believe right around Channel Islands. As the navigator, we are the person who is the middle person between the science team. So the scientists are sitting behind us. They're telling us what they're interested in, and they've done that as well in the dive plan. So we're following the dive plan. I'm talking to the ROV pilots to see what I need to do to get the ship into position for the ROVs. And then I coordinate that all with the bridge. So the captain and the mates on the bridge to tell them what moves the ship needs to make to get the ROVs into position. So that's what the Navigator does. We also keep track of the acoustic system that helps position the ROVs. That's the USBL, or ultra short baseline. And again, we're active front row, so it's a really cool experience to have been able to transition into doing that as well. Mapping coordinator, you're kind of in the data lab doing your thing. You don't get to be as active a part, but when you're up there in the front row, it's super exciting, and you really feel like you're really part of everything that's happening. So I've really enjoyed that. In addition to those two primary jobs, anyone who's part of the OET team assists with pretty much anything and everything. So we all assist in deck work. So when you see those ROVs being launched and recovered, if you're watching Nautilus Live, that's us doing that. So top left, I'm deploying a National Geographic drop cam. There I'm attaching Hercules to the sway arrestor, which is hard to do. And then we're deploying Hercules. In the picture in the kind of bottom left that's kind of blocked out, we're recovering Argus, and that again was 3 women up there recovering Argus, which was the first time that happened. It was super cool. I'm learning how to drive the crane. So this was in preparation for our last expedition. I was loading on a winch plate with the crane. I'm not in the picture towards the bottom right, but that's my colleagues, Shannon Hoy and Eileen, I forget her last name, smashing bait, but I also did that, and that was part of the drop cam deployments, and it's gross, but we do that as well. And then there's a very glorious picture of me just a few days ago power washing the vehicles. So we do everything and anything that needs to be done, and we're always ready to help any other member of our team whenever they ask. So a little bit about ocean mapping basics, if you're not familiar. Again, I'm a mapper by training, so I came out of Slippery Rock with a GIS background and then learned a lot about acoustics. We map the ocean or the seafloor and the water column with acoustics because acoustics are what transmits the deepest and longest through water. So an acoustic pulse is transmitted from the ship. It travels to the seafloor and returns. And from the two-way travel time of that acoustic pulse, and our knowledge of the speed of sound that we measure with different instruments, we know the depth of the seafloor. With a higher frequency acoustic system, you can get higher resolution data, but higher frequencies can't travel as far. So to get to full ocean depths, you use lower frequencies. We're using 30 kilohertz. True full ocean depth systems are at 12 kilohertz. And then our sub-bottom is at is 3.5 kilohertz. So that's a low enough frequency to actually penetrate the seafloor and give us information below the seafloor. We also get the intensity of the scattered sound from the seafloor, and that's kind of what's in the background of this picture. That's backscatter. From the intensity of the return, we can get some idea of the seafloor character, if it's a harder material or softer, and so we can do some characterization or interpretation. Below here, this is what bathymetry looks like when we collect in high resolution. We also get returns throughout the water column. So on the left, there's an image of a water column sonar fan, and that's what it looks like when we go over a seep. We get this high intensity return in the water column, which is pretty cool. And that's how we can map bubbles, fish. And then in the center, it's hard to tell, but that's a shipwreck. So if you go over like an archaeological artifact, that will also pick up in the multibeam sonar in the water column. And so you can get information about ship structure. And I did do an expedition earlier this year where we were diving on shipwrecks, which was pretty cool. And just to kind of talk about why we're mapping, if you look at something like Google Earth, you may think that the entire seafloor is mapped. So this is a image on the left is of Google Earth, if you're familiar. But most of that information comes from satellite altimetry. So it's just an estimate of what the seafloor looks like. On the right is a more realistic view of what's actually mapped. So the bright parts are mapped with multibeam sonar. The dark parts are just done with something like satellite altimetry. And so you can see once you get away from the main Hawaiian Islands and the coast of the west coast of the US and Alaska, there's a lot of unmapped area. And so that is why we are always mapping. We map before we put the ROVs down, but we map anytime we're on our way somewhere to help fill in some of those gaps. And so we'll talk a lot about mapping the gaps. And this is part of an initiative called Seabed 2030, where we're trying to fill in all those gaps by 2030. It's probably not possible, but it's really nice to have this kind of organizational effort to bring everyone who's doing ocean mapping around the world together to try and aid this mission. So on our way to Hawaii, we'll be actively working on filling gaps in the map. And this is just focusing on the US. 53% of the US coastal, so that's within our exclusive economic zone, 53% is unmapped. So what you're seeing in red is areas of the US exclusive economic zone that have not been mapped. So that you can see it's a lot that we haven't done, and we have a lot of resources. So if we haven't done it, you can imagine what most other countries have been able to do. Also in the Great Lakes, most of the Great Lakes have not been mapped. So that's a priority. A group called Lake Bit 2030 is trying to prioritize getting the Great Lakes mapped as well. Okay, so how did I get to the Nautilus? So I was in Slippery Rock in 1999 to 2004. It took me 5 years. Everything takes me a little longer, and you might recognize some of those faces. I was environmental studies minor in geology and geographic information technology. I did go out to the Badlands with Dr. B and Dr. Livingston for at least 2 years. I couldn't quite remember. I did an NSF with the University of Southern Maine as well, where I was doing both geology and GIS. So it was a great combination of both my interests. And I got to go on multiple adventures. I was part of the Outdoor Adventures staff, so did caving and things a lot. Went to Newfoundland with Dr. B, went to many conferences to support the Badlands work, and really just had an amazing experience at Slippery Rock because of the opportunities that were made available to me there. When I left Slippery Rock, my first job was at the USGS in Woods Hole, Massachusetts. And just to kind of talk about what got me there, I was hired for my GIS skills. Sure, it was great that I had a geology background and stuff, but they needed somebody who could do GIS. So that's what got me that job. And I was doing the geology work for a scientist named Paige Valentine. He was a geologist. I think he did paleo work as well. And he was doing habitat mapping off of Stellwagen Bank. So this was my first introduction to seafloor mapping data. I'd never seen multi-beam data or any kind of seafloor mapping, didn't know anything about it, but he was doing his habitat maps on top of already mapped seafloor data. So that was the first time I saw it, the first time anyone explained to me how we mapped the seafloor, and that's how I really started to learn about it. But I was doing straight GIS work for him, like drawing polygons and stuff. I also got to go to sea with him twice to do kind of ground truth surveys where we were towing cameras to ground truth his habitat maps. And also on the right, I got to do some tunicate work in the nearshore area. There was an invasive tunicate that he was watching, and we would put sensors in one of the nearshore areas of Cape Cod and would go to check those. And on the left, that's me and some of my friends during the last Alvin commissioning, which was obviously like 2005 or something. Alvin is a deep sea submersible that's in the bottom left and is being recommissioned again. So it's quite interesting how time flies. From USGS, I was hired by a software company. So this was a software that USGS used. I had never heard of it. They were hiring and sent the announcement to colleagues at USGS who came in and asked me if I wanted a real job. So I was interested in this job because of the travel. It listed 50% travel, and I thought that sounded amazing, and I still think that sounds amazing. And it was great. So it was a software company that specialized in seafloor mapping data. So I went from having some idea about seafloor mapping data to dealing with it every single day with clients who knew a lot about it. So it was really kind of a trial by fire to learn about seafloor mapping and multi-beam sonar data. And I was a technical sales and support. So I was in sales, but I was going to visit clients to explain how the software worked, to take their data, show them how to get it in, think about their workflows and how we could help them. So it wasn't sales, it was definitely more technical, but I got to travel around the world and it was great. It was a job that I never would have thought existed, never would have thought to look for. And again, it was my GIS skills, but also some familiarity with science that got me this job, because I was going to have to deal with this mixed clientele who had science backgrounds or survey backgrounds and be able to understand what they were talking about and then explain how they could do it. So that's, again, it was the GIS that really was the key skill here. So a big push for taking that GIS minor, learning about GIS. And I was there for nearly 10 years and really learned a lot about multi-beam sonar. But I got to the point where I learned everything I could on my own, and I was really frustrated that I didn't really have the true technical background in multibeam sonar. So I decided to leave, and this was about 6 years ago. Oh, sorry, I forgot to mention this. This is also, while I was at IVS, it was also where I met people from the Nautilus. So I went to work with a group, University of Delaware, and on the bottom left, the red box is around my boss now, Nicole Renault, but a much younger version of her. So when she was in grad school, I did some work with her, and then she became the VP of Science here at Nautilus. I also met Dwight Coleman and Katie Croft, who were early members of the Nautilus team, and went to train young interns who were coming out on the Nautilus when it first started. So that's how I kind of made that networking connection to the Nautilus team. But then I left in 2015 to do a master's in ocean mapping with one of the groups that I had come to work with a lot, which was the Center for Coastal and Ocean Mapping at University of New Hampshire. So they have a specialty in ocean mapping where you're really learning about the acoustic side and the mapping systems. And it's good to point out that in order to get into that program, I had to take Calc 1 and Calc 2. So I push you to take as much math as possible. You're going to have to eventually if you want to get into anything like this. And I also did not have to take it ahead of time, but it was very much trial by fire that you had to code. You were expected to do everything, all your exercises, all your work was coding. And so we did it in MATLAB. They've since moved to Python. Either will work, but if you want to get into anything like this, even if it's not going to be your daily plan, you need to be able to get into data and dig around to really understand it. So it would push you to learn some coding skills. Still a grad student because I'm finishing my thesis, but I'm oh so close, and I'm looking at water column data off of Peterman Fjord in Northwest Greenland. Super cool. And during my graduate work, I had a lot of opportunities as well. One of them was to get out on the Nautilus, which is the next slide. But I also got to go to New Zealand to do a water column experiment with a group there. Did some mapping off of the Marianas Trench, super cool. So tons of opportunities to get out on different ships and do different mapping expeditions. But what was exciting for me becoming a grad student is I finally got to go on Nautilus. So as an employee of IVS, we were always watching the Nautilus. They would use our software. Occasionally, users of our software would be out, and so we would watch what they were doing. We would watch them from our conferences and stuff. Loved what they were doing, and I always wanted to go out, and my boss would never let me go out. He wouldn't let me take a month to go play on a ship. But when I got to grad school, I knew Nicole, who was the VP, and also on the top left there is my advisor, Larry Mayer, and he's on the board of the Nautilus. So I had new people who were connected to the Nautilus. And so my first summer, I contacted Nicole, and I didn't apply for an internship or anything because there was a really good connection between my university and the Nautilus where they needed mappers. And so they would just have you come out and you wouldn't even be an intern. They would just expect you to start working. So it was really, really cool, really good. And so middle picture is my first year on the Nautilus as a mapper. I'm assisting kind of the front row to prepare for a dive. Then the left is Larry Val Schmidt, who's also at CCOM, and myself. And that was during, I believe, 2017 when we were doing some expedition work. My first year I came out supported by UNHCCOM, so they just let me stay on my stipend for that couple of weeks. But then after that, I would take unpaid leave from my my stipend work at my graduate work, and then I would contracted to work on the Nautilus. And so now I'm out anywhere from 60 to 150 days a year. To the left side here, that's the UNH team as well with their ASV. And on the right, that was our approach into Hawaii a few years ago, coming into Honolulu. So that's my story. So a little belated now, we'll change over to Alyssa and let her tell a little bit of her story before we finish up with some highlights of Nautilus expeditions. Go ahead, Alyssa.
Okay. Well, my path is obviously much shorter and probably less exciting. But I really started, I was always interested in the ocean, but, you know, being in the middle of PA, I thought I was never going to get to do a career with that. But in Dr. Schiappa's oceanography class, we learned a lot about bathymetric mapping and the history behind it, and it really caught my interest. So later in the fall, when I was looking for internships, I really searched extremely hard to get to see anything that was out to sea. I applied for probably 10 different experiences, and I ended up getting one on the STEM Seas program, which is like a 6 to 10 day experience aboard a research vessel, and it's during transits. So when they don't have a full staff of scientists on board, they go to different places every year and on different ships. I was lucky enough to get on one that went from San Diego to Seaward, Alaska for 10 days. And we had 3 mentors on board that kind of taught us different aspects and different areas of geoscience research that could be done at sea. One of them was she did work with high metals. Another one was Annalise from one of the I'm sorry, one of the Alaskan universities. She did work with eDNA, and we got to use minions, which code DNA out in the field. And then the last mentor we had was a glaciologist, and he taught us a lot about different areas of that research. So while we were on board, we got to do different lectures with them, but we also got to take part in different at sea onboard things. Like we stood watch in the bridge for 8-hour shifts. We got to do work in the data labs and the science labs. We also were part of a recovery mission for a wave glider, which you can see on the bottom left there. We also got to take samples off of it because there was weird things growing on it. So we took samples from that and we put it through our eDNA samplers. And we just overall had a lot of fun and learned a lot about different areas of research. And it was where I first got to see onboard mapping systems, because they had a mapping system on board. And we got to spend some time in that data lab. So it was a lot of fun, and if anybody is interested in science research or at sea research, I suggest you go apply for that. And that's what kind of gave me the experiences to know that I liked being on ships. So a year later, I applied to the Nautilus and got accepted as a seafloor mapping intern. You can change the slide, Erin. Thank you. So I applied to the OET Science and Engineering internship, which I went under the track of seafloor mapping, but they have 5 different tracks. I was accepted for the 2020 season, but with the COVID pandemic, they got delayed until 2021. So after getting my bachelor's at Slippery Rock, I can now finally get on the Nautilus. And my duties will be to stand watch for 8 hours, doing monitoring the multi-beam and sub-bottom profile eco sounders, doing det work, processing acquired data, and obviously other tasks as needed. We'll also have to do outreach while we're on the ship, because there's science communicators on ship, which I'm excited about. But yeah, I'm excited. I'll be there next week, but other than that, I don't have much to say.
That was great, Alyssa. Thank you. And soon we'll have your picture that you could put your face there in your Nautilus gear. I was going to try and Photoshop one last night for you, but
No,
ran out of time. So I
visual
think this
captions
was,
are cute enough.
yeah, this is a good substitute. But yeah, we very much look forward to it. Thank you for sharing your experience on how you got here.
Yeah, thank you.
All right, so I'm going to try and finish up as quickly as possible. Sorry, I've been talking longer than I expected, as usual, but I thought I would go through some of my favorite expeditions, just 3 of them, some highlights. One of my favorite mapping expeditions was our first approach to Hawaii. This was, I believe, 2018. It was when Kilauea was erupting very, very actively. And as we approached to Hawaii, it was getting towards the end of that, but still active. And so as we arrived in the middle of the night and early morning, we could see lava flowing off the island. And then we came in as close as we could and ran multi-beam sonar over that area. So we were mapping brand new seafloor. And this XKCD cartoon just caught all of us because this was, we thought we were heroes. We were running in to map as quickly as possible. And that's the group of us toasting marshmallows over the hot lava. So we had a great expedition, mapped a lot of seamounts on the way, and then got to map over brand new seafloor, which was just stunning and amazing. Another favorite of mine is Monterey Bay National Marine Sanctuary. So I'm actually going to cut out of the presentation here and just play the video of this while I talk about it, if I could do it quickly enough. I'm actually not trained to do stuff in this control van, so, oh, maybe not. Let's just go back to that. Well, there's some really great video. I recommend you go check it on Nautilus Live. But around Monterey Bay, we had 2 expeditions and 2 amazing experiences. NA 103, we came upon what we were calling the octopus garden, and this was a complete surprise. Thousands of brooding octopuses on the seafloor, all rolled up over piles of eggs, brooding their eggs. And so in the top center there, it's an egg clutch, and there was actually a little octopus being born. It was super cool. And they were following the areas where warm water was escaping. We saw them following fault structures, such, and it was stunning, a complete surprise, and one of the coolest things I've ever seen in my life. Thousands of octopuses. Also in Monterey Bay, we came across a fairly recent whale fall. So that's the top left. And this was the first time we've seen a whale fall where things were feeding on it, including bone-eating worms. I can't remember their scientific name, but it was incredible. Octopuses and fish crawling all over it. The top right is actually me. I'm in the front row, you can't see me, but myself and the pilots arriving at this whale fall and exploring it. It was stunning. Left is the Argus view of Hercules looking at the whale fall. 2 of the coolest expeditions, both in the same sanctuary. Great video highlights on Nautilus Live. And the fun part about watching the video highlights on Nautilus Live is you hear our reactions in the control van and what we're talking about. And sometimes we're like joking around, but like often we're stunned by what we're seeing. And so you can feel the excitement of the control van. And then, of course, can't not mention Expedition Amelia. This was 2018, I believe, as well. We were out with National Geographic to Nicamaro Islands looking for Amelia Earhart. So Dr. Ballard was a pretty big part of this one. He's there top center with myself and my partner, Lindsay, and Allison Fundus, who's one of our chief officers, I forget which one. She's in charge, and we were planning what to do. So it was very intense trying to look for this plane. We had camera crews following us around, but it was a complete pleasure to work with National Geographic on this expedition. We did get to go to Nicamaro at the end, so we took a small boat in and got to take a swim. That's myself and a few of the pilots. That's Jess Sandoval, she's our ROV pilot, and Nova West, who was a documentarian with National Geographic, and we were eating some coconut. Incredible experience. Top center is a coconut crab. If you've ever heard about them, they're huge and scary and frightening. But super cool to work with National Geographic and then to see our team highlighted in a National Geographic documentary. So super, super cool. So coming up with Alyssa, NA 132, we are heading to Hawaii. It's hard to see, but that blue line is one of our track lines. It keeps changing, but we're going to try and map gaps on our way to Hawaii. It's about 4,000 kilometers. It'll take us about 10 days to get there, running the multi-beam sonar the whole way, doing what we can to get the best data we can. We'll also be deploying SOFAR buoys. So we just deploy these buoys at places they request in the ocean, and they get meteorological data that's broadcast back to the SOFAR network and also publicly available. And we're going to be deploying one of these little boats. This is a little boat that's made by one of the schools locally that has sensors and stuff on it and also broadcasts information back. So they'll be following their little sailboat as it crosses the Pacific. So that's our plan for NE-132, which will take us into Honolulu in end of October. And then the end of the season, we'll be spending the rest of the season in the Hawaiian Islands, Northwest Hawaiian Islands. So in the Google Earth image, that's the Hawaiian Islands you know about. We're going to be way up here doing mapping of seamounts and also ROV work. The left is our planned mapping up in that area, so some really extensive mapping of this chain of seamounts to try and figure out, well, in preparation for ROV dives next year, where we'll do sampling to try and understand the origin of these seamount chains, because they're doing interesting things up here. So that's what we'll be doing for the rest of this season. The season ends mid-December in Hawaii, and I'm still undecided whether I want to come home or stay in Hawaii. It's hard to come to New Hampshire when it's cold and wintry, but that's the plan. So that's it. Thank you for listening to our presentation. Thanks, Dr. B, for the invitation and your ongoing support my entire career. Colleagues and friends on the Nautilus. Alyssa will obviously wants to thank me for letting her be part, of course. I wish you were on the ship with me. And please follow us on Nautilus Live and just keep update on what we're doing. They'll be doing interactions and stuff with Alyssa, myself, and the rest of our team during this mapping expedition. And so that's it for us. I know it's probably close to the end and you guys have sat quietly. But if you have any questions, we're happy to take them.
All righty, well, let me speak for a minute and let you know that numerous professors that were mentioned and pictured in your presentation are with us today. It's a very fair statement to say that we are extremely proud of both of you, and you're carrying our Slippery Rock name forward magnificently. I'm really looking forward to seeing Alyssa give a presentation in 15 years with a long tally of awesome successes like that. I thought I would stop this for a moment and give a shout out to Dr. Bob Ballard, because I've been following his career for much of my career. And these days, you know, we understand that there are black smokers and white smokers on the mid-ocean ridge, where fluids have circulated through the hot crust, dissolved a lot of metals and sulfides and other things like that. And then they come jetting out as superheated streams of hot water. And I remember either reading or seeing his account from the Alvin, when he first came upon one of these. His thermometers on the hull of the submersible showed that the water was getting hot. And one of the frustrations that you'll often hear from people who made those dives is that they can't see much beyond the range of their lights. So they're always wondering what is just beyond. And what is just beyond started to come into view as he realized that the smokers, the rising hot water, were driving a vigorous convection current, and he was losing control of the submarine as it was being pulled toward the hot smokers. So he jammed his thrusters into reverse and was still losing ground, and the submarine was being pulled into those things. So he had to quickly scamper to turn off instruments that were drawing current to allow as much electricity as possible to go to his thrusters to back away from what he felt was an imminent loss of life. He felt that if the temperature got too hot, the submersible could lose its strength and he would be crushed there on the bottom of the ocean. So it's a really magnificent story of discovery. And I love the fact, Erin, that you've been involved in trying to find Amelia Earhart and other people. I followed your story as well. I want to give another quick shout out to Alyssa, because she mentioned that she applied. And it's crazy because you ladies are taking OPM, other people's money, to a very high level. It would be astounding to know what it would cost you to be on those ships per day as a tourist. It's a very expensive operation. Anything marine is 10 times as expensive as anything terrestrial. So the cost of of the experiences that you have are really astounding. And I just loved that Alyssa said she applied. One of the things that is persistently unbelievable to faculty is how hard we work to encourage students just to apply, to have incredible opportunities and have other people spend money on them. So I thank you both for that, and we'll give you another round of applause. There's a few students left in the audience. We are going to take this tape and put it up as a YouTube channel, so you will be able to share it with family and friends in the future. And I'll ask if anyone in the audience has a question now. Questions, anybody? One or two? Way in the back.
So Erin, when are you actually going to be finished with the degree?
Jack wants to know when you're going to finish that master's degree.
I have to finish. I've gotten the 6-year warning. I'm doing my corrections right now, and I plan to defend during our break it should be like February. So yeah, time is tight right now. And I'm sad Alyssa's not here, but I'm happy for this chunk of port days because I'm going to be down there doing my corrections right after this. But thanks for the push.
We wish you luck in that regard. We all know something that the students could learn is that undergraduate credits persist forever. If you got halfway through a degree, you could come back 50 years later and finish that degree. But such is not the case for master's and PhD credits. They are time limited. And if you don't finish the degree, those credits expire. So Erin is feeling the hot breath on the back of her neck of her favorite old professors, and I'm sure family and friends and thesis committees and advisors, everyone is now rooting for Erin to finish up. Sounds like a 2022 diploma. So we look forward to hearing that good news. And someday, once again, on our way to Maine, we'll stop in New Hampshire and buy you a beer.
Please do.
Please, yes. Well, we're going to sign off from here then. Thank you very much, both of you. It was really magnificent, and I'm so stoked that we got the technology to allow us to be together for an hour. Fair winds and following seas.
Thank
All right, thank you all. Thanks for
you.
your attention. All right, bye-bye.